Welcome to the exercise of the Allylic script, okay, from Chem 6161, a stereoselective reaction. And basically the first exercise, we have this compound, and we are treating this reactant with borane, and then we oxidize with hydrogen peroxide. What we are doing is a borohydration followed by oxidation to get an alcohol. Okay? Here we have the double bond that will be where we will take the reaction, and here we have a chiral center in the alpha position. First thing that we need to do is to draw this in the lower energy conformation. I will put all this group, I will talk like R, okay, in order to make easy the drawing. Then I have the double bond here. I have the furan, and here, if I put the hydrogen down in order to diminish the syn-pentyne interaction between this metal and this hydrogen, okay, the metal is in front and all this group is behind the slide. And now what is happening is the borane is coming. Remember that in the case of a borohydration, okay, the hydride will go to the most substituted part of the double bond. That means that we will have this, while the boron is coming to the less substituted part of the double bond. And now what we have to decide is in which side of the double bond we will have the reaction. If we do this, okay, if the boron is coming from in front, it's facing a metal here, while if the boron is coming from behind, it's facing all this group that by far is bigger than not a metal. That means that aesthetically the reaction will take place from the face of the metal. That means if we draw it, what we have this compound with the hydrogen and the boron common from this part. If I draw it a little bit better, what I will have is okay. I will have this compound, okay, I only draw it this a little bit better, and then after oxidation what is happening is that I transforming this boron in an alcohol, and I will get I will have this final compound. Okay? Summary, what I have to do is basically draw the lower energy conformation of this compound, taking into account that I need to avoid as much as possible the syn-pentane interaction. That means growing the double bond in the plane of the slide with this substituent here, with the cis substituent here. This, I have to put this chiral center in the way that one substituent is in the same plane as the double bond and in the same direction as this substituent, and has to be the smaller one. In this case, I have a methyl, I have this group, and I have a hydrogen. It will be the hydrogen that is going down. If I rotate this to put the hydrogen down, the metal is coming in front, and this R group, all this group is coming behind. Then, obviously, the approach of the boron has to be from this phase, and I draw the final product, and then I do the oxidation to get the alcohol. Okay? Good. Well, then we are going to the exercise number 2. In the exercise number 2, they say that what I have is I have this compound and what I am adding is a triple bond with copper acetate, and they say that I get this compound. Okay? And they tell us, give the structure of the order diastereomer that we can obtain. Okay, and second, draw the transition step. Draw the Hug model of the conformation that leads to the observed major diastereomer. Okay. We will start by the easy way, that is to draw the order diastereomer. Basically, the order diastereomer has to be with the inversion of this chiral center. That means that what we will have is okay. And now they say that we have to draw the lower conformation. Okay, the lower conformation basically, okay, in this case, is when the allylic alcohol, well, sorry, the allylic position, okay, has to be the lower substituent, the smaller substituent, in the same plane of the double bond and in the same direction than the cis substituent. That means here. If we check this center, what we have is we have a benzyl oxy, we have a hydrogen that is coming in front, and we have a metal. Which is the smaller one? Obviously the hydrogen. That means we put the hydrogen here. If we put the hydrogen here, what we have is that the metal is in front, and the benzyl oxy, is behind the slide. And now what is happening is that it's coming the cuprate. The cuprate, if we only saw the sterics, obviously a methyl is smaller than a benzyl oxy. That means that the attack has to be from in front. However, because it's a copper and we are forming a cuprate, the active species is this. Okay. What is happening is that this copper coordinates with the oxygen, okay, and this is the directing group that will attack. That means that this alkene will attack by the same phase where we have the benzyl oxide. It means that the double bond, the alkene will attack by the same phase where is the benzyl oxide, obtaining this final compound. Okay, in this case it's clear an example of a directing group where the copper coordinates with the benzyl oxide to make that the triple bond attacks by the same phase where is the benzyl oxide. Okay? And that's all. Thank you very much for your attention and see you in the next lecture.